Welcome! Today's guest is Martin Kronberg of Intel. You're going to show us how to build a little robot with the Arduino 101 powered by the Intel Curie. Is that correct?
That's right.
Awesome. Take it away, Martin.
Cool. Thanks, Alex. Hey, guys, how's it going? Like Alex said, my name is Martin Kronberg. I am a tech evangelist over at Intel, which means that I basically make some cool projects and share it with people, developers like yourselves. And today, I am showcasing a robot that was built using the Arduino 101, which is Intel's Curie system on chip mounted onto an Arduino Uno board. So basically, the shields that are compatible with the Arduino Uno. It's compatible with all of the sketches that you would use for an Uno. It has some features that kind of put it apart. So it has a Bluetooth radio built in, and it also has a 100 neuron machine learning setup. So it's a little bit more powerful, and you have to definitely do some interesting projects with it. Specifically today, what we're going to be doing is leveraging the Bluetooth radio in order to basically just create a simple little remote control robot, but that I think has the potential to kind of spawn off more interesting projects. And I'll maybe talk about that as well. And first, I'm going to talk about the hardware that goes into this guy. The chassis was a multi-chassis four-wheel drive that we got off of SparkFun. It's pretty solid. Something falls off of it. Aluminum. It has a lot of little slots on it to install sensors and anything else that you need. It's pretty nice, actually. In order to actually drive the motors, we got a Adafruit version 2.3 of their DC motor and stepper motor shield, which runs over I2C, and as well as an extra battery pack, since the 5 AA's didn't really provide enough voltage to run the Arduino 101 Bluetooth, as well as the actual process itself and the motors. So basically broke it out and had two different banks of batteries, one for the motor and one for the Arduino. So the assembly, it comes with assembly instructions if you get the kit, and I've also included it in the Hackster write-up. And you basically follow that with a couple caveats. You have to install the standoffs for the Arduino 101 before you finish assembling it, because otherwise you can't really screw it together. And then on the back, I attached the second battery pack with just some Velcro, and it works fine. And other than that, it's just the instructions that come with the kit, and it's really just screwing some motors and putting the chassis on. It's not too bad. So once we have all of that assembled, you have to wire it up, and there is a wiring diagram. It's pretty straightforward. I mean, you just take the motors, and the way that I have it is that starting in the upper left corner, it goes motor 1, 2, 3, 4, going clockwise. So basically, you have to go to input or motor output 1, motor input 2, 3, and 4, and make sure that you get the polarities correct. And then the code that will be provided later should just work outright. If you build this and one of the wheels seems to be spinning the wrong way, you either have the polarity flipped or it's in the wrong port. So I don't know. It's not too bad, but you just got to kind of keep in mind that there's going to be a lot of wires floating around. So what I did was paired the two positive and negative leads from each motor together and taped them together. So that way, at least I'd have the same motor each time. Also, the battery pack needed to be soldered together, or at least the barrel jack needed to be. So that was a pretty simple job. The one kind of tricky bit of soldering was for the Adafruit shield, because mine came with the pins not soldered in. So it was just basically kind of a little bit it's not too bad if you've soldered before. I would definitely recommend practicing on something if you've never soldered, because the tolerances are a little bit tight, and if you bridge two pins with solder, you have to clean it out. It can be kind of a pain. So just keep that in mind. But yeah, once you have it all assembled, it should look something like that in the picture, where you have the four wheels, you have the battery pack in the front for the motors, the battery pack in the back for the Arduino Uno sitting on some standoffs with the shield on top. And if everything's wired correctly, you should be good to go. All right. So now we're going to talk about the software a little bit. And basically, there is two main components of the software. The first one is what's running on the board, and the other one is what's running on your laptop. The model that I'm trying to do here is to put all of the control of the robot onto the laptop, and then just send the signals to the board, and then from the board to the wheels. And likewise, send any sort of signals that maybe if you have a sensor attached, you would just put those signals into the board and then send those raw data up to your computer. That way you can have more complex control systems in place. For instance, what I want to do eventually with this robot is attach it to like a ROS control system where a webcam will be monitoring it from my computer and then driving it around like an obstacle course or something like that. And basically what we're doing here is establishing that bridge of connecting the Arduino board to your computer over Bluetooth.
By ROS, you mean Robot Operating System, right?
Yes, by ROS, I mean the Robot Operating System, which is, if you're unfamiliar, it's a really fascinating framework for controlling robotics, where basically it's almost like a shell that runs on top of a few different operating systems, but the simplest one to install it on is Ubuntu, where it has its own layer of communication protocols where you essentially link different processes, such as a motor control system to OpenCV computer vision system to like a mapping SLAM type of thing, so simultaneous location and mapping, and then you tie that all together within the framework. So it's a standardized API for robotics, essentially.
Awesome.
And I just started learning it not too long ago, so no means an expert, but it seems really fascinating. It has a lot of potential. Yeah, so I mean, and basically something that complex can't run on an Arduino. So if you offload all of that processing to a laptop or some sort of host computer, then you can start doing a lot more interesting, like autonomous driving, maybe like mapping of your room they were in or something like that. And that's where I kind of want to go with this eventually. And so in order to establish that connection, what we're using is a piece of software called Fermata, which runs on the Arduino and essentially virtualizes the GPIO pins on the board to your laptop so that your computer can interact with the pins like it was native to itself, right? And this normally runs over USB. And in order to get it to run over Bluetooth, we also have to use something. Okay, also, sorry, step back. So everything on the computer was programmed in Node.js. So I used a couple of different packages using NPM, right? So the Fermata is installed on the Arduino. And in order for it to communicate over Bluetooth, I used a Bluetooth serial module, which essentially makes a Bluetooth look like a virtual serial port to the Fermata running on my laptop. And the Fermata that's actually running on the laptop is not just raw Fermata. It is part of the Johnny 5 framework And if you guys haven't used that, it's a Node.js based robotics / IoT framework that has a lot of different libraries and pre-configured components. So basically, it has a pre-configured component that that describes the Adafruit motor shield and all of its I2C registers and addresses and all that stuff. So you don't have to really go. Well, at least I didn't. I don't know. I didn't really want to. I don't know if I could even. But if you were going to use raw Fermata, you would have to basically send I2C commands to certain registers on the I2C bus at a certain address or something like that. So it was kind of over my head. But luckily, Johnny 5 already has that built in. So I just used that and used the BLE serial module in order to allow it to communicate over Bluetooth. And finally, I also used a little library to read incoming keyboard presses from my laptop keyboard, and then send that through. And that's kind of the overview of the software. In order to actually get it to install, you would use the Arduino IDE in order to load this the sketch, and you would use Fermata standard BLE, which comes pre-installed with the latest version of Arduino IDE. And so you just load that up over USB. And you basically, if you never use the Arduino IDE, it's pretty straightforward. You just go to file examples and load up the standard Fermata BLE sketch, click upload, and then if everything goes well, you get a little message pops up that says sketch starting in 5 seconds. And so you're good to go with that. The Fermata client on the computer running on Node.js, like I said, you have to install Node.js on your computer. There's a link in the Hackster write-up. So you just install Node.js and follow the link, and it runs on Windows and Linux and OS X, and I did this all on my Mac. So once you install the JS, you have to install the 3 packages that I talked about. So Johnny 5, which is going to be the framework, KeyPress, which is going to be the one that captures your keystrokes, and BLE serial, which is the package that's going to virtualize the BLE over serial port. And once you have that, you can get the control code, which I have it linked to my my GitHub where I just have the control code, and I can pull it up and we can kind of look through it right now. But once you have all those steps done, you can download this code and run it, and then once your laptop connects over the Bluetooth, you use WASD to drive the robot, and that's pretty much it.
That's an adorable robot.
Thank you. So I always keep everything unplugged just so it doesn't drain the battery power. But in order to get it to run, you have to have the battery pack that's going into the voltage in on the board from here plugged in, and then the barrel jack from the battery pack in the back going into the Arduino 101 to actually power the Arduino 101. And when you plug it in, give it a little bit of time to boot. Not it doesn't take too long, maybe 5-10 seconds. And then we're going to run that code. Basically, then you can
ramp it off the table. See if you can hit the whiteboard.
Oh my God. Okay, well, anyway, so it works. But anyway, So then, at this point, you basically have that basic control where, granted, you're the one that's sending the controls manually through the terminal, but you can just as easily use that same, communication protocol to send commands that the computer generates for itself. So if it has a webcam that's watching this thing driving around, and you can do some kind of object recognition on it, you can follow around, and it can direct it around obstacles and things like that. So that's kind of the idea, is to set up that basic connection between the computer and the robot. And I guess I can go through the code real quick here. So, Node.js, we sharing code here. We have the Johnny 5 package. We have the BLE serial package and the keypress package. Now, the way that this BLE serial package works is it was written specifically for the Arduino 101. So it's going to go out and it's going to find the first Bluetooth device that's broadcasting on an Arduino 101, essentially SSID. I don't know if that's what it's called for Bluetooth, but it's basically like Arduino 101 dash the last 4 digits of the MAC address. So that part is hard coded, which makes it really easy if you have one robot, because it just finds your robot and connects. If you have more than one, you might have to use a different package, and maybe I'll make an update to the code at some point and include doing multiple robots. But for now, this works. I didn't really have any issues with it at all. Once you have the serial port open here, you create a new Johnny 5 board where you set the port to that BLE serial port. Repel false basically means that it's not going to wait for commands from you. And yeah, and once you have the motor, or once the board comes online, you load up the configuration for that Adafruit Motor Shield version 2, and you instantiate 4 motors with that config that you loaded up, and then at outputs M1, M2, M3, M4, which correspond to the first, second, third, and fourth motor, which once again, the way that I did it is the front left wheel is the first one, the front right is the second one, and it goes around clockwise. And then I just made some simple functions to go forward, back, left, and right, where, using Johnny 5, all that stuff is kind of hidden from you, or, well, it's a bit of a higher level abstraction. So you have just motor 1.reverse. It's not like you have to actually turn on certain pins like you would with maybe a more basic motor driver board, where you set like one pin to high, one pin to low, and a PWM to set speed. It kind of abstracts that for you. But basically, in order for it to drive forward, some of the wheels have to drive forward, some of the wheels have to drive in reverse, but that's just because the half of the motors are flipped 180 degrees. So those, they all run in the same direction, but they're not all mounted in the same direction. So basically, you just have to keep that straight. So forward, reverse, left, right. I'm just doing simple tank controls. So if it turns left, the right wheels turn forward and left wheels turn back. So it just kind of rotates around the center. And also a stop function where just all 4 motors stop. And then in order to actually send commands to it, I'm using that keypress package, where you just set it up to listen for keypress events. And then here I have it set up so if it gets a keypress event and the key's name is W, it goes forward at the speed of 255. And likewise for S, A, D, and Q just stops it. And that's pretty much it, right? So we have the connections, we have the motors being instantiated, and then the control functions, and then the listening for the key press events. So yeah, and that's pretty much it.
Cool. All right. So Thank you so much, Martin, for joining us. It's fantastic. We'll be sharing this video to go along with our global Hackster Live meetup. So if you want to build one of these in person, come join us. You can go to hackster.io/live. This will also be supporting one of our upcoming contests, so watch out for that. And going on up as a virtual workshop. It's a triple hitter. Super excited. Thank you again, Martin.
Awesome. Cool. Awesome. Thanks. Yeah.
All right.
All right. All right, guys. Good luck. Have fun.